All right, today we're going to decode the body's command chain. I mean, how does a simple thought in your brain actually turn into an action, like picking something up? And maybe even more importantly, what happens when that chain breaks? We are talking upper versus lower motor neurons, and trust me, by the end of this, you'll see the critical clues that tell them apart.
It seems so simple, doesn't it? You think, grab that coffee, and bam, your hand just does it. But behind that one tiny action is this incredibly precise two-step signal that's got to travel all the way from your brain to your muscle. So today, we're going to follow that signal and see exactly what happens when that connection gets cut.
You know, every single voluntary move you make, from walking to talking, it all comes down to this command chain. It's this elegant two-neuron system, and its whole job is to transmit orders from headquarters, that's your brain, out to the troops on the ground, which are your muscles. It's the basic wiring that turns our thoughts into actions.
And here is the absolute best way to think about it. This is our analogy for today. Just picture a manager sitting in the main office, the brain. This manager decides what needs to get done. Then they send that order down to a worker who's out in the field, right there at the muscle, ready to do all the heavy lifting.
So let's put some official names to these roles. In one corner, we've got the upper motor neuron. That's our manager up in the brain. And in the other corner, the lower motor neuron, our worker on the front lines. Honestly, understanding what each one does is the key to this whole puzzle.
So their job titles are basically defined by where they live. The upper motor neuron, our manager, starts way up in the brain's motor cortex. It sends its command all the way down the spinal cord. And from there, the lower motor neuron, our worker, takes the baton. It sends its own signal out from the spinal cord directly to the muscle. It's just a perfect two-part handoff to get from thought to action.
Okay, but what happens when that signal gets messed up? What if the manager can't talk to the worker, or what if the worker gets cut off from the muscle? Well, this is where we get into the clinical signs of a lesion, and the clues are dramatically different depending on where that break happens. And this right here is the crucial point. The damage can happen to the manager, or it can happen to the worker. And the specific symptoms that show up are like a diagnostic map, telling a doctor exactly where in that command chain the break has occurred.
Let's start with muscle tone. Okay, with an upper motor neuron lesion, so the manager is gone, the worker neuron is left totally unsupervised. It kind of goes haywire, gets all over active and excitable, and that leads to increased muscle tone or spasticity. But if the lower motor neuron is gone, the worker itself is just out of commission. No signal ever reaches the muscle, so it just goes completely limp. We call that flaccidity.
Now, what about reflexes? Well, think of the manager in the brain as constantly sending these little calming signals down to keep our reflexes from totally overreacting. So when you lose that manager in a UMN lesion, the reflexes just go wild. They get super exaggerated. That's hyperreflexia. But if you lose the worker in an LMN lesion, the whole reflex circuit is just broken, and the response is either really weak or completely gone.
Now there's one reflex that's a particularly powerful clue, the plantar reflex. In most adults, if you stroke the bottom of the foot, the toes curl down. But with a UMN lesion, something kind of strange and primitive comes back. The big toe actually extends up while the others fan out. With an LMN lesion, you just get a weak response or nothing at all.
Yeah, that upward-going toe is such a big deal, it's got its own name, the Babinski sign. It's a primitive reflex we all have when we're infants, but it's supposed to get suppressed by our mature brain. So seeing it show up again in an adult is one of the clearest signs that the manager's calming control from the brain has been lost.
What about the muscle itself? Well, with a UMN lesion, the muscle isn't being used the right way, so you get some mild atrophy just from disuse over time. But with an LMN lesion, the muscle has lost its direct lifeline, its nerve supply, and this leads to really profound, rapid muscle wasting. The difference in how severe it is, it's striking.
Here's another telltale sign you can actually see. They're called fasciculations, those small little involuntary muscle twitches you can see right under the skin. You don't get them with UMN lesions, but with LMN lesions, they're super common. You can think of them as the last, desperate signals from a dying worker neuron.
So when you see these twitches, it is a massive clue that the worker neuron, the lower motor neuron, is in trouble. It's lost its connection from up high, and it's just firing off randomly as it degenerates. It's a real hallmark of an LMN problem.
And finally, there's something called clonus. This is a series of rhythmic, involuntary muscle contractions that you'll often see when a doctor quickly stretches a muscle. It's really just another sign of that out-of-control, exaggerated reflex response you see when the UMN manager is offline. You're not going to see it when the LMN worker is gone.
So we have this really clear pattern of signs, right? Spasticity and hyperreflexia point to the manager, while flaccidity and wasting point to the worker. But what kind of real-world things could actually cause this kind of damage in the first place?
For upper motor neuron lesions, the problem has to be in the central command center, so the brain or the spinal cord. We're talking about things like a stroke that damages the motor cortex, a spinal cord injury that just severs the pathway, or diseases like multiple sclerosis that attack the nerve insulation inside that central system.
Now, for lower motor neuron lesions, the damage happens after the signal has already left the spinal cord. This could be a physical injury to a peripheral nerve, a pinched nerve root right where it exits the spine, we call that a radiculopathy, or even infections like polio, which specifically target and destroy these worker motor neurons.
I know that was a lot of information, a lot of different clinical signs to keep track of. But don't worry, we've got a fantastic little memory hack to lock all of this in place so you will never, ever mix them up again.
Okay, here it is. For upper motor neuron lesions, just think U for UMN is for up. This means the signs all go up. You get increased tone, which is spasticity. You get increased reflexes, which is hyperreflexia. And that Babinski sign we talked about, the toe points up. See? Simple as that.
And for the lower motor neuron, well, L stands for low or for loss. You get a loss of muscle tone, flaccidity, a loss of reflexes, and a profound loss of muscle bulk. Just remember, UMN signs go up, LMN signs mean a loss. It's truly the simplest way to keep it all straight.
So there you have it. We've cracked the code for how our bodies move. It's this simple manager-worker system that, when it works, is absolutely seamless, and when it breaks, it gives us these really precise clues about where the problem is. It really makes you wonder, doesn't it? What other incredible command chains are running your sensory systems, your thoughts, and your memories right this very second?